Hey all, welcome to another screencast. In this screencast, we're going to be looking at state variables in smart contracts on the Ethereum blockchain. In the last video, what we did was we introduced the basic concept of a smart contract and introduced the structure of a really simple smart contract. We're using the Remix IDE, which is available for free right within your browser. And we're using this to compile and deploy smart contracts to a test network so that we can kind of just work out our knowledge and practice a bit. So in this video, what I'd like to do is talk about state variables. And what do I mean by state variables? So basically, if you're familiar with object-oriented programming at all, or just basic programming in general, we have this idea of a variable. Right? And a variable is just a location in memory where we can store information. And that information can have different types. We can have like numbers or letters. We call them series of letters called strings. And we can store that information and then we can manipulate that information using different functions and different lines of code. When we're talking about a smart contract, we talk about variables that reside within the contract itself as a state variable. Now, in traditional object-oriented programming terminology, we would call this a property of a class. So in smart contract development, we call it a state variable. And this is super important to understand as we start to get deeper into smart contract development. Most of what a smart contract does is manipulate state within itself. And state could be, for example, say the balance of a given token for a given address, or the balance of an NFT token within a specific address. This is all state variables that are stored within smart contracts. So the last smart contract we wrote was really simple. We have it here on the screen. It's a hello world contract, and it has a single function here, a method that returns a static string called hello world. We saw how to compile it, deploy it, and then run it right within Remix. What I'd like to do now is show you exactly what this would look like, but with a state variable. So state variables we would typically create right within the beginning section of our contract. And we can go ahead and type out any type of state variable by giving it a type and giving it some visibility. So we can make it public, we can make it private, and then we can give it a name. So we could say, maybe call it hello. Now I'm going to make this one, well, I'll make it private for now. And what we could do here is I just hit save there. We can assign a value to it right within the constructor. So the constructor is a special type of function that gets called when the contract is first created or when it's instantiated. So when the actual contract is instantiated, we can go ahead and call this function, and we could say hello equals hello world. Now, instead of the say hello method just returning a static string, we can go ahead and say return this private string variable called hello. Now, this is going to complain because what's happening here is that our function here is declared as pure, which basically says we don't touch or manipulate any of the state variables. Now, we don't want it to be pure anymore because we do touch a state variable here, but we don't change anything. So what we can do is we could say that this is still a public function, but it is only a view function. That means that we're not changing any of the state variables, but we are accessing them. So we're good to go. Now we're returning that hello. So let's see what happens. We should get pretty much the same functionality. So if we go here, we're going to say compile. Okay, it compiled. Then we'll go here and this is showing us. Then we'll go here and we'll hit deploy. Awesome. We got a good solid deployment. Now within Remix, we do see a bunch of different deployed contracts. This is going to show you any deployment that you did. One important aspect of this is every time we do a deployment, we're actually creating a whole new contract address. So as you're developing your smart contracts and you're running deployments, you're essentially recreating the entire software package that is the smart contract on the blockchain that you're deploying to. So that's important to note if you're going to, like, say, mainnet and you're deploying new versions of your code, you're fully deploying the smart contract again. That old version still exists. There's ways where you can upgrade contracts and point them. We'll get to that much later on. But for now, it's important to realize that every time we deploy, we're creating a new instance of this contract. So we can drop down here and we can see that these are the different deployments that we've done. I've got a couple here that I've been playing around with. And you can see here, this is the last one that we have. Now you'll notice we only have the say hello method. And if we call it, we're going to get hello world, just like we did in the beginning. But we're accessing now this private state variable. Now state variables can be different types. In this case, we used a string. And one kind of downside to this, using a string, is if you go here, you notice how we're getting this big scary warning here saying the gas requirement of the function say hello is infinite. The point here is that it does cost gas to store information on the blockchain. You can think of each one of these state variables as a record, or I should say a field within a database. And this information is going to be stored permanently on the blockchain, and that costs gas. Specific blocks of information cost a certain amount of gas. Ethereum, the EVM, works in 32-byte words. So the way that storage works within a smart contract is the compiler will try to pack in information into 32-byte words. And those 32 bytes are then stored in a stack on the actual blockchain. So in this case, because we declared a string has a variable size. So this warning is basically saying, hey, I don't know how much data you're going to be storing within this field. So I'm going to tell you right now, this could go and get pretty pricey if you make a lot, if you have a really large string that you're storing within this property. In our case, we've statically assigned it right within this constructor, and we're not really changing it. So the risk here is pretty low, but there are some ways to get around this. You can use fixed size variable types, say, for example, like a bytes 32 to store this information. Now the compiler knows that, hey, this is a 32-byte size property that we know the size, so we know exactly what the cost is going to be. In this case, the level that we're at now, we don't have to worry about that. We can go ahead and use it just like this. So the next thing I want to highlight here is the private. What does that mean? So private basically means that access to this variable is only achievable from within this smart contract itself. We will not see or be able to access information within this variable outside of the single instance of Hello World. And you can see this here because we don't have any access to this within the UI here of the contract. So what if we change this to, say, public? Public is going to automatically create what we call a getter function on this variable. A getter function is basically just a function very similar to this function that will just return this given variable's value. So in this case, we actually don't even need this say hello function anymore because we're going to automatically get a getter. So let's see what that looks like. So if we go ahead, save this, and let's go ahead and compile it again. Okay, and then let's deploy it. So I get deployed. And now if we go here, you'll see instead of just having the say hello function, we also have hello. Now if we click hello, that's going to call the getter that we get for free by just making it public, and we'll be able to see what the value is. Now we should get the same value when we say hello. We call the say hello function. And there we go. So we got the same exact output. So that's really the basics of state variables within a smart contract. And in the next video, what we're going to do is we're going to dive into a little bit more complicated example where we can maybe use an array, which is like a list of information, or maybe a mapping where we can map a list of two different values together, say an address and a balance. So for now, we're really just looking at primitive variables, primitive types, right? And we can have strings, we can have int 256. So this would be an integer value, and we can just have some number here, right? The byte 32, which we saw, and we'll just some bytes. We can have Boolean values, which Boolean values are just bool, are just true or false, so some bool. Right? This is just a true or false value. And there are a bunch of different types of primitive types within Solidity itself that we can actually declare. Now, one unique one, if you're familiar with other programming environments, these are probably pretty familiar to you, but one that is unique to Ethereum and just blockchain development in general is the address. So the address type is basically a variable type that allows us to declare some address on the blockchain. So we could say blockchain address, right? Or whatever we want to call it. And what we could do here is we can store a specific address, say for example, a receiver of some payment or even another smart contracts address, right? Now this is a 20 byte size value, which is the size of a regular Ethereum address. And if we were to return it here, we can use that to reference the address. So which is really, really useful when we're talking about blockchain development, because we are very much using addresses all the time when we're developing. When we deploy this smart contract, it's going to have an address assigned to it. When we need to send Ether or some other token someplace, we're going to have to send it to an address. So understanding these types and how to use them is really important. Understanding how the storage is laid out within a contract when it's developed is important. And I'm going to go ahead and post some links right in the notes here that outline some of this stuff pretty clearly in terms of the layout of variables. And this becomes really important when we start to talk about inheritance and upgradability within your contracts, because the storage is laid out in a very specific way. Basically, it's a stack and it's just listed on top of each other. And it uses what's called big endian storage. So this is stored first, this is stored second, third, fourth, and so on. And there are certain rules in which these could be packed together, because the EVM is going to always try to fit everything into 32 byte words. So that's the basics of state variables within a smart contract. If you have any questions, please post them in the comments below. I'm trying to keep these videos as short as possible within a 15-minute time span. So I may be rushing a little bit here, but let me know if there's any other details that you'd like to address. We're going to continue to work some of this knowledge out. And in the next video, we'll talk about arrays and maps, and we'll see how that differs a little bit from what we're seeing here with some of the primitives that we can use within smart contract development. All right, have fun. Thanks.